All right, hello everybody. Let's talk about cross multiplication. This is a phrase I hear coming up a lot from my students, and there seem to be a lot of misconceptions around the use of cross multiplication, and often it seems like it's more harmful than helpful. So first, let's start off with a scenario where you can actually legitimately use the technique that is known as cross multiplication. So here we have a basic proportion type of problem involving some direct variation. So it says if you work for 10 hours, you make $120. If you work for 15 hours, how much will you make? So there's obviously many different ways to solve this, but one way would be to set up a proportion. So you could say 10 over 120 is equal to 15 over x. And let's just see what this means, right? What is this saying? This is saying that the ratio, right, the ratio of 10 hours to $120 is equal to the ratio of 15 hours to x number of dollars. So obviously this is assuming that you make a constant number of dollars per hour. And it's saying that if that amount, that ratio, right, that ratio of hours to dollars, dollars to hours is constant, then you can take the initial data point that you have, which is 10 hours and $120, and set that ratio equal to the ratio of $15 to x hours. Okay, now how do we solve this? Well, I think many people, their first impulse would be to cross multiply. So people would draw this little x and create a cross multiplication and write 10x equals 120 times 15. And at this point, they would pull out their calculators and plug in 120 times 15, even though, as you guys know, you should try to do mental math whenever possible. So the answer would be 1800, right? Because times 15 is really the same as times 1.5 and then times 10. So anyway, mental math, we can save that for another day. But you get the answer is x equals 180. So if you work for 15 hours, you would make $180. Okay, great. So we use proportions, we use cross multiplication, and we solve this problem. All right, so have you ever stopped and wondered, why does cross multiplication work? Why do we do that? Why do we draw this little x right here, just kind of mindlessly, and then multiply across this equal sign and solve? Like, where does that even come from? Okay, well, let's actually see where it comes from so that we can understand it. General rule of thumb. If you can't explain what you're doing to someone else, even better, if you can't explain it to a 10-year-old, why are you doing it? You probably shouldn't be doing it if you can't really explain what you're doing and justify it. Okay, so let's try to justify why cross multiplication works. So let's just take a generic proportion, a over b equals c over d. Now remember, a, b, c, and d are variables, and they can stand for anything. Okay, anything, numbers, other variables, doesn't matter. Now, let's say we want to get rid of the fractions and turn this into a different form that doesn't have anything in the denominators. Okay, so as we've seen, you can cross multiply. But where does that come from? Well, first of all, let's try multiplying both sides by b. Okay, there's a b on the left in the denominator, so let's try to multiply both sides by b to get that b out of there. So we're going to get a over b times b equals c over d times b. Now, on the left side, there's a b here and a b there. They cancel out, okay? One b is in the denominator and another b is in the numerator. The whole point of doing that, multiplying both sides by b, was to cancel out the b's, okay? So they cancel out. And we get a equals bc over d. If you're not following where I got that from, pause the video right now. I'm serious, pause it, and figure out, how did I get that? How did that work? Okay. And then once you get that, you can multiply both sides by d, and you would get AD equals BC over D times D. And again, these D's cancel out, so we get AD equals BC, which is exactly what we got by quote unquote cross multiplying. Okay, so really there's nothing special, nothing magical about cross multiplication. It's just sort of a shortcut for doing this two-step algebraic process where we first multiply by one of the denominators on both sides, and then we multiply by the other denominator to both sides, and we get rid of the denominators. So really it's a straightforward process that you could have done without ever learning this technique known as cross multiplication. And there's nothing magical, nothing special about it. Okay, the biggest problem that I see, and one of the reasons why I hate the term cross multiplication, is it's confusing. People think that cross multiplication is a type of multiplication. It's not. Cross multiplication is not a multiplication, which is why it's terribly named, right? People think that because the word multiplication appears in cross multiplication, that anytime you have multiplication, you can cross multiply. But you can't, because cross multiplication is not a kind of multiplication. Cross multiplication is a really bad name for this technique where you take things and you multiply them across in this specific situation, right? Where you have this proportion, you have this equal sign, and it represents this two-step algebraic process. Okay, so cross multiplication here is a shortcut but it's not a type of multiplication. Let's see what I mean by that. Let's say you have a fraction, a over b, and you want to multiply it by c over d. I kid you not, I have seen people try to cross multiply these. And I don't blame them, right? Because we drill this idea into their brains that, oh, fractions, cross multiply that. Well, you know what? That doesn't make any sense. That is absurd. Okay, think, like, let's just see what would happen. Then you get, like, what would you even get? You would get, I don't know. Let's try to make this work. BC over AD. Well, why would you get that? You could just as easily get the other way around. You could also get, I don't know, AD over BC. I mean, I don't know what you're supposed to get when you do that, but I see people try to do it because they see multiplication, they see fractions, and they think, I got to draw this little x, I got to cross multiply. But you can't, okay? It's really not that complicated. It's a fraction. When you have a fraction and you multiply them, you multiply the numerators and then you multiply the denominators. The answer is AC over BD. Okay, this is all sort of abstract in terms of variables. Let's see it with an example, okay? Let's see, something like 3 over 4 times 5 over 7. Okay, 3 over 4 times 5 over 7. I think with these numbers, with these fractions, most people would realize, okay, it doesn't really make sense to cross multiply here, right? Let's say, you have some fraction 3 out of 4, and then out of that you take 5/7 of that. So you're just going to multiply the numerators, and you're going to get 15 over 4 times 7, which is 28. Okay, you just multiply the top and you multiply the bottom. Okay, so far, so good. Let's see what you would get if you did cross multiplication. Let's just see what you would get, okay? You would cross multiply. And again, I'm not exactly sure how this is supposed to work, but you would either get something like 28 over 15 or 15 over 28. Or sorry, my bad. You would either get 21 over 20 or 20 over 21, both of which are just not even close to being the right answer. Okay, so these are not right. Okay, so for an even more extreme example, let's say we were doing something like 1% of 1%. So that would be 1 over 100 times 1 over 100. If you did this using so-called cross multiplication, you would get the answer would be 100 over 100, or 1, or 100%. So if you take 1% of 1%, you somehow get back to 100%, which is clearly absurd. Okay, so that's just don't even write that down. Don't ingrain that in your muscle memory. It's just bad. Okay, so don't forget that you ever saw that. You don't want to memorize that. So again, when you just have multiplication of fractions, a over b times c over d, don't even think anything about the word cross multiplication. Okay, cross multiplication is not multiplication. If you have this, it's simple. A times c over b times d. Okay, great. Now, again, most people, I think, realize that, okay, when there are real numbers in your fractions, sort of common sense comes to you and you realize it doesn't really make sense to, quote unquote, mix up the numerators and the denominators using cross multiplication. Okay, but using rational expressions with variables in the numerators and denominators, I think people get a little bit more confused. So if you had something like, I don't know, x plus 2 over x squared plus 6x plus 9 times, I'm sorry that the times here looks like an x, it's not an x, times x plus 3 over x squared plus 4x plus 4. Again, these are just examples that I chose. If you're multiplying these two rational expressions, don't even think about cross multiplying, all right? You will just make a mess. You will get into a very complicated situation if you start doing that, and it's not going to get you the right answer. Okay, as I've talked about before, whenever you have rational expressions, it's really, really useful to try to factor them. Okay, so you would, in this case, try to factor each of these trinomial denominators. Both of them are perfect square trinomials, and try to cancel them out. Okay, so you would do that, and then once you've simplified as much as you can just multiply the numerators and multiply the denominators. All right, so just to recap, a over b, if you have a proportion, a over b equals c over d, it does indeed end up equaling ad equals bc. Okay, so you can use cross multiplication if you insist, if you really, really want to use that terminology and you feel confident about it, I will not stop you. However, if this is going to confuse you, if you worry that you might start accidentally or otherwise applying cross multiplication to other situations when it's not called for, when it's just normal multiplication, I would say just steer clear of it, okay? Steer clear of it. Don't refer to it as cross multiplication. Don't get it into your mind that it's a type of multiplication, because it's not. It is really, really dangerous to start using processes and techniques that you can't fully explain and can't justify just as a matter of procedure. If you can really understand what you're doing and understand how you're manipulating the variables and the algebraic expressions, that is good. That is what you're going for. But if you're just doing something because you remember it from a couple years ago in some class, or some tutor showed it to you once, or a classmate showed it to you, you got to be really careful. It can really lead you down into very dark and dangerous places. All right, so that's it for tonight. Thank you for watching, and remember, cross multiplication is not multiplication. Thank you.